Hello, this is a short video presentation on solving linear equations. Why do we solve linear equations? Or more specifically, why do we solve equations at all? Engineers, scientists, computer programmers, economists, etc. use equations to model real-life situations. We solve equations to get the answers to those situations, those problems. Solving equations is also a basic skill that you need to be successful in your future math classes and science classes here and at the university. This year, we will be looking at several different types of equations. This unit will be looking at linear and absolute value equations. Linear equations have a variable with an exponent of 1. Quadratic equations have a variable with an exponent of 2. We'll be looking at radical equations, basically simply square root equations, although we'll have other roots also. And at the end of the year, if there's time, we'll look at exponential equations where the variable is in the exponent. Some basic rules. Number one, as always, show your work as I'm showing it here. We yesterday did a little pretest with a partner, and from what you showed me, the way Miss Graham taught you to show work is exactly the way I want you to do it. There's no difference. And the next thing is what I call the golden rule. Whatever is added, well, the golden rule is whatever is done to one side must be done to the other. Whatever is added, subtracted, multiplied, or divided, one side of the equation, we do it to the other. Equal opportunity here. And lastly, let's have some fun. All right, the first step is to combine like terms on both sides if possible. Now, to help keep track of both sides of your equations, some people like to put what I call a fence down the middle. All right, so we look for like terms. 4 and negative 8 are like terms. Negative 2x and negative 3x are like terms. So we combine these. 4 plus negative 8 is negative 4 plus 3x equals negative 2x plus negative 3x. We add the coefficients. We add the negative 2 and negative 3, and we get negative 5x plus 12. All right, step 2. Distribute if possible. This problem has no distribution. We will do one more example where we do distribution. And since there's no distribution, step 3 does not apply. Combine like terms if possible. We didn't distribute, there are no more like terms to combine. Next, we want the variable on one side. We want the constant, the number, on the other side. So we are going to add or subtract. Now the variable can be on the left or the right. I always choose based on wanting my coefficient to be positive. Not important, just what I like to do. So I have a negative 5x and a positive 3x. I am going to add negative 5x. I'm sorry, add 5x to both sides plus 5x. And the reason is the negative 5x and the positive 5x cancel. I like to, I'm not sure what this guy is jumping around. I like to draw a line whenever I add or subtract. You don't have to, but it helps make your work easier to follow. These linear terms here, these canceled, and I have on the right 12. here I have negative 4 plus 8x. Now I'm going to add positive 4 to both sides. Why positive 4? Because negative 4 and positive 4 cancel, and that's what I want. Draw my line again because I'm adding, and I end up with 8x equals 16. Now, the next step is to divide by the coefficient of the linear term. Well, my coefficient of my linear term here is 8. So I divide both sides by 8. And lastly, I end up with x equals 2. And I've solved my equation. There's one more step. We're not going to do it on our next assignment, but the following assignment we will, is to check your answer. Today, we're not going to worry about checking our answer. All right. Our next example will involve distribution. Step 1 says to combine your like terms. I see I have like terms there. And so I'm going to combine them. 4 and negative 1 is 3, plus 3 times negative 2x minus 3 equals negative 4 times the quantity x minus 3. Step 2, distribute. Well, I see that I can distribute twice. Here, 3 times negative 2x, 3 times negative 3. On this side, negative 4 times x, negative 4 times negative 3. And I end up with 3 plus negative 6x minus 9 equals negative 4x plus 12. Now, truth be told, I could have combined my like terms here and distributed all in the same step. This step right here could have been combined with this step. But I showed them to you separately just to break it down piece by piece. All right, next step, again, combine like terms if possible. Well, I see I have like terms here. So I have negative 6 minus 6x equals negative 4x plus 12. Now, we're almost done. We add or subtract. I have a negative 6x and a negative 4x. I like my coefficient positive, so I'm going to add 6x to both sides of the equation. Again, I'm going to draw my line. These cancel, and I get negative 6 equals 2x plus 12. Since I have chosen to have my variable on the right, I'm going to subtract 12 to both sides. I subtract 12 because those cancel. And I end up with 2x equals negative 18. Last step, divide by the coefficient. So I divide both sides by 2. And I ran out of space. We end up with x is equal to negative 9. All right, real briefly, we combined our like terms. We distributed wherever it was possible. Sometimes it'll be on one side, sometimes both sides, sometimes neither side, as in our first example. After we distribute, we combine like terms, once again, looking at each side separately. So my 3 and my negative 9, we combined here. Then I decide where I want my variable. I chose to put it on the right side, so I added 6x so that those canceled. And then, since my variable is on the right, I had to get rid of this 12 over here, so I subtracted 12 to both sides. Lastly, I divide by my coefficient to both sides so that those cancel, and I have my answer, x equals -9. That's not a very nice looking 9, but it's 9. All right, I hope this helps, and based on what you showed me yesterday, for most of you, this is review. I hope you guys have a great weekend and have an absolutely wonderful rest of the day. See you Monday.